Hello children, I hope all of you are fine. I welcome you all to 9th standard science class. Let us consider the lesson today, atoms and molecules. You have learned about matter and what is it made up of in your previous class. What is matter made up of? Matter is made up of very minute particles called atoms. In this class, let us learn about the two laws of chemical combination formulated by Anthony Lavoisier and Joseph Proust. After many experimentations, these two scientists, Lavoisier and Joseph Proust, they formulated the two laws of chemical combination. You have learned about these laws in 8th standard. Let us recall in this class once again. What does the first law of chemical combination state? The laws of chemical combination. The first law is the law of conservation of mass. The law of conservation of mass. What does it state? It states that mass can neither be created nor be destroyed in any chemical reaction. What does it mean? You have learned that reactants react to form products in a chemical reaction. Here, the total mass of reactants before the reaction will always be equal to the total mass of the products after the reaction. This is nothing but mass can neither be created nor be destroyed in a chemical reaction. Let us write the law. What it is? The law of conservation of mass states that mass can neither be created nor be destroyed. Means total mass of reactants, equal to total mass of the products. Now, what about the second law of chemical combination? It is nothing but the law of definite proportions. The law of definite proportions. What does it state? As the law says, in a chemical substance, the elements are always present in definite proportions by mass. That is law of definite proportions. In a chemical substance, what does the law state? In a chemical substance, the elements are always present. Elements are always present in a definite proportion by mass or in definite proportions. By mass. What does it mean? If you take a chemical compound, water, then it consists of two elements called hydrogen and oxygen. They combine in a ratio 2:1. Means 2 atoms of hydrogen combines with 1 atom of oxygen. But by mass, how much it will be? Water is a compound made up of hydrogen and oxygen. Hydrogen and oxygen. The law states that water consists of these two elements in definite proportion by mass. In the sense, the mass of hydrogen means the atomic mass of hydrogen is 1. Since 2 atoms of hydrogen means it is 2 grams and 1 atom of oxygen means it is 16 in the sense in mass it is 16 gram. Now if you simplify 1:8 so that the compound water consists of hydrogen and oxygen in the ratio 1:8 by mass. The same way, if you consider ammonia, it is having 2 elements, nitrogen and hydrogen. Here also, these 2 elements, nitrogen and hydrogen, combine in a ratio 14:3 by mass. So that the law of definite proportion states that in a chemical substance, the elements are always present in definite proportions by mass. And you have learned about, after these experimentations, John Dalton proposed atomic theory. You have learned in your previous class about the postulates of Dalton's atomic theory. You have to write those postulates in your notebook. That is your home assignment. Write the postulates of Dalton's atomic theory in your notebook. Now, let us consider the symbols what we write for elements. Chemical symbols. We can represent the elements symbolically. The first scientist who used symbols to elements was John Dalton. Now, Berzelius suggested a method to write symbols for elements by writing 1 or 2 letters of elements name. Nowadays, IUPAC, International Union of Pure and Applied Chemistry, approves the names of the elements and symbols are given for the elements. Now, how to write the chemical symbols for elements? Let us consider an element hydrogen. Hydrogen. Look at here. Hydrogen is the English name of the element. H is the first letter which will be written in capital H. So H is the symbol of hydrogen. And oxygen. O is the symbol of oxygen. The first letter is O and we write the symbol O in capital. Now, nitrogen. The symbol of nitrogen. Can you tell? The first letter is N and the symbol we write is capital N. The same way, suppose if the first letter of 1 or 2 elements will be the same, then we consider the first 2 letters of the elements, English name of the element. Now, for example, if you consider argon, here A is the first letter and R is the second letter. First letter A will be written capital and the next letter will be written small. So argon symbol is AR. And another element if you consider bromine. Bromine. If you write B, boron has B. Symbol of boron is B. So you can't write B for bromine. We consider Br. First two letters we consider. Bromine. Br. First letter capital, second letter small letter. Like that, we can write many elements, symbols, taking either the first letter or first two letters as the symbol. Calcium, Ca. Magnesium, Mg. Like this, we write the symbols. Now, suppose if the first two letters also same for two or more elements, then we consider the next letter after second. Later letter which one comes after second, that will be considered. That is, for example, chlorine. We do not write the symbol of chlorine as CH. We write the symbol as Cl. C capital and L small letter. So that H we don't write. The later letter is used to write the symbol. So Cl is the symbol of chlorine. The same way we write symbols for other elements also. And suppose if these also cannot write, means two or more elements have the same letters, then we will consider the Latin or Greek names of the elements to write the symbol. Let us consider some of those elements which we consider the Latin names or Greek names and write the symbols. Or Greek names of the elements are considered and symbols are written. For example, silver. Here we cannot write S as the symbol because sulfur has S symbol. Sulfur has S symbol. So Si also we cannot use because Si is the symbol of silicon. Then what to do? We use the Latin name of silver called argentum. So the Latin name of silver is argentum and we write the symbol as Ag, not Ar. It is the symbol of carbon. So the later letter we consider Ag. So argentum, silver, which the symbol is Ag. The same way, gold. Its Latin name is aurum. And we write the symbol as Au. First letter capital, next letter small. So like this, there are many such elements which we consider Latin or Greek names. Like for example, Pb, plumbum. We write Pb as the symbol. And potassium. P is already the symbol of phosphorus. So we cannot write. We use Latin name K. Like this we write the symbols. There are many elements and their symbols are given in your textbook. You write those elements and their symbols and practice at home. That is your home assignment. Now can you tell me the symbols of some common elements? Nitrogen N, oxygen O, hydrogen H, calcium Ca, argon Ar, bromine Br, silver, argentum name we consider Ag, gold Au, potassium K, phosphorus P, silicon Si, boron B. Like this we write the symbols. Go through your textbook and write the symbols and practice. Now, let us try to understand what is a molecule. Already you have learnt in 8th standard that a molecule is constituted by the chemical combination of two or more atoms. Suppose if two or more atoms of the same element combine, it will be the molecule of an element. and if the two or more atoms of different elements combine, then a compound, it becomes a molecule of a compound. Now let us try to understand molecules of elements. So how do you define the term molecule? A molecule is defined as the smallest particle of an element or a compound which is capable of independent existence, which has the properties of that substance, or which has all the properties of that substance. So can you define a molecule? Is the smallest particle of an element or a compound, of an element or a compound that is capable of independent existence, having all the properties of that substance. All the properties of that substance. Now, what do you mean by molecule of an element? Molecule of an element consists of the same type of atoms. So, hydrogen molecule consists of two hydrogen atoms only. Oxygen molecule consists of two oxygen atoms only. So, molecule of an element consists of the same kind of atoms. Now, this number of atoms which constitute a molecule, we use a term here called atomicity. What do you mean by atomicity? It is nothing but the number of atoms. The number of atoms constituting a molecule. Constituting a molecule is called its atomicity. Is called its atomicity. Some elements such as helium, argon consists of molecule of one molecule of helium or one molecule of argon consists of only one atom. So helium molecule is made up of one atom, argon molecule is made up of one atom. Such even neon also, one molecule is made up of only one atom. We call such molecules monoatomic molecules. What is it called? Monoatomic molecules. So can you give examples for monoatomic molecules? Helium, neon, argon are called the monoatomic molecules. Now, which are some elements, molecules of some elements like hydrogen, oxygen, nitrogen. Molecules are made up of two atoms. Two atoms. We write H2, O2 and N2, means two atoms of hydrogen form one molecule of hydrogen. Two atoms of oxygen form one molecule of oxygen, and two atoms of nitrogen form one molecule of nitrogen. So when the molecules of elements consist of two atoms, we call such molecules diatomic molecules. Di means two. What do we call them? Diatomic molecules. So depending upon the number of atoms constituting that molecule, we classify them as monoatomic molecules, diatomic molecules, and polyatomic molecules. Means there are more than two atoms in some molecules, in molecules of some elements. For example, phosphorus, one molecule consists of four atoms. So we call it tetraatomic molecule. Tetra means four, means poly it is also. Sulfur, one molecule of sulfur consists of 8 atoms. We call these polyatomic molecules. Polyatomic molecules. Let us consider the other part of the lesson in the next class. You have to write the symbols for the elements. That is your home assignment. Let us see in the next.